when you are working in the whole software development life cycle, you need to try to test security in different phases of software development. Software security should not be shooting once the software has been deployed, because usually it's not worth it, it doesn't work. So since the very beginning, you should develop your software thinking about security risk. So once you get the requirements, or you try to make use cases, and right there you should add, not just think about functional requirements, which is what usually the customer wants, but you also have to think about possible risk and try to add some security requirements right in the beginning, and then try to, during the whole process of software development, try to analyze what kind of risk are you adding. It depends on your design, on the model. And one of the most important stages is when you are actually, once the code is developed or you are developing the code, you need to review your code. According to the paper, 50% of the security risk or weaknesses are found during the code review. So I think it's very important that you can read it. You can use maybe white box analysis, or use some tools that can help you find some of the weaknesses in the code. Then you can use do some risk analysis. Risk analysis is it's like a way of it's like a checklist where there are the already known threats to your already known threats, and you try to see, well, does this code is exposed or is vulnerable to buffer overflows? Well, then you check if it's not vulnerable, and then you look for format strings or maybe SQL injection, depending on the software you were working. And right at the end of the software development, there is a penetration testing or ethical hacking, which is probably a tiger team, a bunch of guys trying to exploit the code, trying to exploit the software, trying to find vulnerabilities. It's more of a creative team, that it's not the usual kind of programmer or engineer that do this kind of analysis, and usually are people with a lot of experience in the field. And once the software development reaches the very end, sometimes you need to go back to the very beginning and start the process all over again, because sometimes if you find some security weaknesses right here, probably they survive all this life cycle. Probably there are problems with the use cases, with the requirements, or maybe with the design. So you have to start the whole process all over. There are many kind of weaknesses, but some of the operating systems security issues maybe could be access control, or attacks for malicious software. So you create a software, you try to that software not be vulnerable to attack of all the softwares like viruses and stuff like that. One of the very classic weaknesses of systems or operating systems is buffer overflow, where the software tries to reach to some memory sections that are not supposed to be used for the program, and probably they can invade the operating system memory section and then perform some tasks, some illegal tasks. Some of them are the weaknesses of passwords. People can do dictionary attack, brute force attack, or probably cryptanalysis in order to identify possible passwords so they can have easier kind of access And there are password attacks and rainbow tables. Rainbow tables are a kind of dictionary attack, but the words are already hashed. They're already in hash format instead of just text. There are other kinds of, you could have open ports that you don't know of, and people cannot, software or people cannot actually attack you through some open ports. Rootkits, which are some kind of malware that try to, it tries to all the time conceal itself and to do perform some unexpected or undesired functions, but they always try to hide themselves. And at the end, finally, operating system vulnerabilities like firewalls, missing updates, all that kind of vulnerabilities are the ones that affect operating systems. When you develop software, usually people try to concentrate on functional requirements. They want to achieve what the software is supposed to do. But what security testing tries to accomplish is that the software just do what it's supposed to do and nothing more. There are no extra functionalities. Sometimes programmers try to be a little bit more creative and try to add functionalities that are not in their requirements. And that is, while the programmer is not trying to do something bad, it's